Okay, today we're going to talk about sequences. Sequence is something you already know. A sequence would be something like 2, 4, 6, 8. That's an example of one, and it keeps on going. So that is an example of a sequence. The term is the value in each sequence. So 2 is a term, its value is 2. 4 is a term, its value is 4. The nth term means how far we want to go, and also terms are numbered. This is the term number 1, number 2, number 3, number 4, and so on. If I think about this on a graph, I can think that I've got the first term, the second term, the third term, and the first term is 2, the second term is 4, the third term is 6, and these represent a line. And that's what a sequence looks like. It's models after a linear function. So a sequence is that has a constant change, and in this case, the change is 2. I only use addition or subtraction to create a sequence. There are two forms of an arithmetic sequence, which is what this one is. We're adding or subtracting. There's one form is called the recursive. The other form is called the explicit. The change between the two consecutive terms, that means in this case I'm counting by twos. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So that change of 2 is called the common difference. Okay, the first thing we're going to learn to do, and it's important as we move forward to both sequences and series, is determining, in this case right now, is this arithmetic or not arithmetic? And we're kind of looking for the common difference when we do this. So I look at 5 to 8, and I think 5 plus what is 8, and that difference is 3. And now I'm going to see if it works between all the numbers in this sequence that I've been given. 8 plus 3 is 11. 11 plus 3 is 14. 14 plus 3 is 17. So it's all threes. So I can finish this sequence by adding 3. 17 plus 3 is 20. 20 plus 3 is 23. And 23 plus 3 is 26. I completed that sequence. So yes, it's arithmetic. And my common difference is 3. The D is 3. Okay, the next one, I'm going to see the difference. So negative 4 plus what is 1? That would be 5. And then 1 plus what is 6? That's 5. 6 plus 5 is 11. 11 plus 5 is 16. That is 6. So this is not arithmetic, so there is no D value. And then the last one is I see that the numbers are going down, so I'm subtracting a number. So I'm going to check it out. 100 minus what is 90, so that would be minus 10. So I check it out. 90 minus 10 is 80. 80 minus 10 is 70, so it is negative 10. Finish the sequence. 70 minus 10 is 60, minus 10 is 50, minus 10 is 40. So yes, this is arithmetic, and the D value is negative 10. Okay, so here are the formulas that we're looking at when we're talking about the recursive or explicit. The first one that we see up here is the recursive form, and it's this formula here. AN means whatever term I'm looking for is a term minus 1 and then adding the D. Makes sense. 2 plus 2 is 4, 4 plus 2 is 8, 8 plus 2 is 10, and so forth. So that is what they're saying, is that A to the n minus 1 means that is the previous term I need to have to get the next one. So the thing over here about recursive, it allows you only to find the very consecutive or that next term. This is not very user-friendly. as we're doing it, unless they give me the start and what the difference is, and I can just add it and get them all in there. So the second form that we're looking at, which we will use more, is the explicit form. And this form I can use to find any term in the sequence. So the variables that we're going to talk about is a of n represents just the nth term value. So when we talk about a, if I write a5, I want the 5th term, a100, I want the 100th term, and so on. A to the n minus 1 is our previous term, and that's the one that happens right before. D is that common difference. A1 represents the first term in sequence. So going back to what I started with of the sequence of 2, 4, 6, 8, 2 would be A1. That is the first term. And N represents the term number. That means how many numbers are in the sequence if I stop, or what term I'm looking for. So that is what the N is, like the N is here. Okay, it says use the arithmetic recursive form, which is what I've given you. This is the arithmetic recursive form to find the following nth term in the sequence. So this is kind of tedious work, but I can do it. So I have to find A1, A2, and then A3 because I'm looking for A3. So A1 is given to us. It starts at 3, and it tells me I'm going to add 6. So 3 plus 6 is 9, and then I got to use 9 plus 6 is 15. So the third term in the sequence is 15. So as you see, we have to have the previous term to get the next one. So this one's a little tedious. Okay, this next one, I have to find the 5 terms. So I have A1, A2, A3, A4, A5, and A1 is 45. So the next one, to find A2, I take 45 and I subtract 5, and that equals 40. And then to find A3, I take that 40, subtract 5, and I have 35. And then for A4, I take that previous term, 35, subtract 5, and I get 30. And then A5 is take 30, subtract 5, and get 25. Well, I don't want to do this 100 times, so this one's a little bit harder to do. But A to the 5 equals 25. Okay, the explicit form is much, much better. So to write this, remember the explicit form is AN, which means any term I'm looking for. I have to have the first term, and then I'm going to add to it the n minus 1 times the common difference. So this is A1, okay? Now, 8 plus 4, 12 plus 4, 16 plus 4. So I have my A1 at 8. My common difference is a positive 4. So now I can write my equation here of a to the nth power equals the first term, which is 8, plus n minus 1 times 4. That is what I'm going to use to find any term. Well, I'm asking you to find A10. So A10 is 8 plus, the n is 10, so I put in place of n 10 minus 1 times 4. Now I can plug this straight in my calculator just as I see it, but the tiny math is not hard. That's 9. 9 times 4 is 36. 36 plus 8 is 44. Okay, the next one, I'm going to do the same thing. I know my A1 is the first term of 36. 36 to get to 30 is minus 6. 30 minus 6 is also 24. 24 minus 6 is 18. That makes my common difference negative 6. So now to write the formula, my first term is 36 plus n minus 1 times negative 6. Now I'm asking to find A8. So A8, the n is 8, so 36 plus 8 minus 1 times negative 6. Now I can do my tiny math, that's 7. Now I have 36, so 7 minus 6 is negative 42, and 36 minus 42 is negative 6. So here you might want to stop and see if you get the idea, and then continue on the video. But I'm giving you A1, I'm giving you the D, I'm looking for A7. So I can write my formula, which is AN equals the first term, which is negative 10, plus n minus 1 times 5. So now A to the 7th is negative 10 plus 7 minus 1 times 5. This is 6. So 6 times 5 is 30. 30 minus 10 is 20. Again, I'm giving you A1. I'm giving you D. I'm looking for the 15th term. I always write my formula first. Negative 10. I'm sorry, I don't know why I said negative 10 because that was the last one. Sorry about that. Let me get that negative 10 out of there. The A1 is 4 plus n minus 1 times negative 8. Now I'm going to find A to the 15th. The n is 15. So 4 plus 15 minus 1 times negative 8. Now I'm going to do the tiny math. That is 15 minus 1 is 14. Now 14 times negative 8 is negative 112. And then negative 112 plus 4 is negative 108. Okay, we talked about earlier how arithmetic sequences look like a line, or they're a linear function. So when I take a look at this problem, it says if the fifth term of an arithmetic sequence is equal to 23 and the sixth term is equal to 27, what is the first term of the sequence and what is the common difference? Well, since I know it represents linear, I can think about the term number and the value of that term as an ordered pair. The term number and the value of that term. So if the fifth term's value is 23 and the sixth term is 27, I can now use those two ordered pairs to find slope. So remember, slope is y2 minus y1 over x2 minus x1. So 27 minus 23 over 6 minus 5 is 4 over 1. So my common difference is 4. Now I can go on and think about the formula that we just learned, which is AN equals A1 plus n minus 1 times D. So when I think about the information that I have an AN there. I don't have an A1, but the N is 5 and the D is 4. So I have enough information to create an equation to solve for A1. So I am just going to substitute those values in. So AN is 23, oops, wrong pen. A1 is 23. Don't have A1. N is 5 minus 1, and the D is 4. So now it's 23 equals A1 plus 4 times 4, which is 16. Now when I subtract that 16, I get 7. So A1 is 7. Now it's asking me to find the 25th term. So AN equals the A1 at 7 plus 25 minus 1 times 4, and that's the math I'm going to do. And when I put this in, I'm going to get 103. So this one is an example just the same. If you want to give it a try and then watch the rest of the video and see if you did it right, this is a good time to pause. So now I'm going to set it up. The 10th term is 75. The 12th term is 89. So now 89 minus 75 over 12 minus 10 is 14 over 2. The D value is 7. So I've got that piece. Now I like to use the first, it doesn't matter which ordered pair you use, I'm going to use the first one. And so AN is 75 is equal to A1 plus the N value, which is 10 minus 1 times the common difference. And now I've got 75 equals A1 plus 9 times 7. 75 equals A1 plus 63. Subtract that 63. And A1 is equal to 12. Now it's asking me to find the 25th term. So A25 equals A1, which is 12, plus 25 minus 1 times 7. And that value is 180. And that is how you would do and use arithmetic sequences. Okay, now we're going to go on to geometric sequences, and they're different. Geometric sequence formula. It models, or it looks like an exponential growth. So remember, when we were studying exponents, I had a exponential growth. So it hovered around the asymptote turned at 1. Or I can have a exponential decay, which starts up high and comes down low. These are how geometric sequences are graphed. So it gives us an idea of what they look like if I put them on a coordinate graph. Okay, the AN equals the nth term value, and we've already discussed what this represents. It tells us what we're looking for. A to the 5th is the 5th term, things like that. Remember, A to n minus 1 talks about the previous term, the one before. A1 represents the first term, so it's all the same values that it represents. N represents the term number. And now the R, instead of a common difference, this one is called a common ratio. Ratio is a fraction. 4 over 1 is a fraction. 1 over 4 is a fraction. And it's a common ratio. And notice that is like the base of the exponent. Okay, this says to write the explicit and recursive form of each sequence, then find the indicated term if possible. That means if it's a sequence. So when I take a look at 5, 15, 45, 135, looks like it's multiplying. So 5 times what is 15? It's 3. Then I check 3 times 15 is 45. 45 times 3 is 135. So this one sets, which makes me have a geometric because I'm multiplying. And if you can't come up with what the ratio is, you could take the second term, divide it by the first term, and it reduces to 3. And I can see that 45 over 15 is also 3, and 135 divided by 45 is also 3. So that's geometric. And remember, geometrics have a common ratio, and this one is 3. The recursive form is just like the recursive form in arithmetic, is I start with that A to the n minus 1, but this time instead of adding the D, I'm going to multiply by the R. The explicit's the one we're going to use the most. That's A to the n equals the first term. times the ratio raised up to the n minus 1. Now I need to find a to the 6, so 5 times 3 to the, that's an 8, to the 8 minus 1. This was definitely calculator appropriate because it's an exponent. Put this in and it's 10,935. Okay, the next one, it's going down, so 1,000 minus 500 is 500. 500 minus 500 would be 0, so it's not arithmetic. Now I'm going to think, is it 500 divided by 1,000 equals 1/2? 250 divided by 500 equals 1/2. So I am definitely geometric. And I have a common ratio of 1/2. So the recursive is a(n) equals a to the n minus 1 times 1/2. My explicit is where it's the a1 value, which in this case is 1,000. My r value is 1/2, and it's n minus 1. And there's my explicit formula. Now I'm going to use that formula to find the 6th term. So 1,000, 1/2 is the base, 6 minus 1. I'm going to put that in my calculator, and it's 31.25. And then the last one here, 12 plus 5 is 17. 17 plus 5 is 22. 22 plus 27, 22 plus 5 is 27. So this one is arithmetic. And this has a common difference. And since I'm adding 5, my common difference is 5. The recursive is where we start with the a to the n minus 1, and this time I'm adding 5. The explicit is a to the n equals a1, which is 12, plus n minus 1 times the common difference. I need to find the 15th, so 12 plus 15 minus 1 times 5, and this one gives me 82. Given either the explicit or the recursive form for the following geometric sequences, write the other form giving the following information. So I'm giving you the recursive and a1. So remember the recursive in this form with multiplication. This is geometric, and that's my r value. So a to the n equals a1, the r value, and n minus 1. Okay, the second one is recursive, so that's the one I start. Doesn't matter which one it is. And my r value is 8, so times 8. And then lastly, I've got a1 at 15 and my r value at 2/3. So a to the n equals 15, 2/3, n minus 1. Okay, given the following, find the indicated term. You can use recursive or explicit form. I like to stick with explicit, so that's what I'm going to do. Give me a common ratio, so this is geometric. Find the 5th term. So the 5th term for geometric is the first term, the common ratio, and now 5 minus 1 because that's n minus 1. And that one's going to give me a to the 5th term is going to be 64. Okay, the next one gives me a common difference. So a difference tells me it's arithmetic. The first term is 4. Find the 5th. So a5 equals the first term plus the n minus the 1 times the common difference, which is 2. And this equals to 12. Now I have it labeled A1 and R. Find A3. It's an R value, so that tells me it is geometric. So a to the 3rd equals the first term. common ratio, and 3 minus 1. Put this in my calculator, and that's 25. And then lastly, A1 is 24. D is -5, so that means I have a arithmetic sequence. And A8, so A8 equals my first term, plus n minus 1 times the d, which is -5. And that value equals to -11. Okay, this problem takes us back when we were studying exponential functions. A chemist is studying the growth of bacteria strain. The number of bacteria in the Petri dish is 550 and doubles every hour. Does this scenario represent arithmetic or geometric? And it's geometric, and the way that I know is doubling means multiplying by 2. So now write the recursive form. So that's the one that we don't use as much. So a to the n minus 1 times the r, which is 2. And then write the explicit form is a to the n equals the first term, and that's what's in the Petri dish. 2 would be the ratio, and it's n minus 1. And that takes us to the end of this video.